Hello, how's it going? In this video I'm going to do some more differentiation with you, trigonometric differentiation. So differentiating secx, cosecx and cotx. Okay? So I've just posed the questions here, differentiate with respect to x. In an exam situation you need to be able to show these results. So for example, they may give you the derivatives of each of these and they might ask you to show one or more of them, but also the results you should try and memorise as well. Anyway, I've set it up so that if you want to pause the video you can do so and have a go. Otherwise, just keep on playing and I'll talk you through it, okay? So the first one, y equals sec x. What I'm going to do is I'm going to first of all write it as cosine x to the power of -1. Because remember, sec x is 1 over cos x, isn't it? Okay, so I'm going to write it as cosine x to the power of -1 because it means the same, it's the reciprocal. And then what I'm going to do is I'm going to use the chain rule. Okay, so differentiating using the chain rule, we have dy dx is equal to, now bring the power in front, negative cosine x, and then that will be power of -2, because I've got to decrease the power by 1. Then I need to differentiate what's in the brackets. Okay, I need to differentiate what's in the brackets. Differentiate what's in the brackets, I get negative sine x. Okay, so what I'm ending up with is negative times negative, so that's positive. I'm going to write it like this, sine x over cos squared x. Okay, because cos x -2 is 1 over cos squared x. And I'm just going to tidy it up a little bit. Now sin x over cos x is tan x, and I've got another 1 over cos x, okay? So that will give me sec x tan x, okay? And that's how you can show that the derivative of sec x is sec x tan x, okay? I'm hoping you understood that. Now, if you couldn't do that one, maybe I'm going to go at this one. Principle's the same, just rewrite this as y equals sine x to the power of -1 first, okay? I'm going to have to move this up a little bit, okay, obviously, because I've run out of space, but what I want to do is I want to work through all of these on the same screen, you see. So I'm just pausing this here. I'm just going to raise that. And what I'm going to do is, because you've probably done with that now, I'm just going to write out the answer again. Normally it's a bit quicker for me to rub this, but as you can see, I'm to use my fingers today because the board pen, for whatever reason, decides not to work. Don't mind, fingers are working, which is useful. So sec x, tan x. Like this one, write as y equals sine x to the power of -1. It's the same as 1 over sine x. Use the chain rule again. So dy dx is to be equal to, so bring the power down, negative sine x, decrease the power by 1 to the power of -2, and then differentiate the sine x, you're going to get cos x, and then we can write that as negative, and that will be cos x over sine squared x. Okay, sine x to the power of -2 means 1 over sine squared x. I'm just going to tidy it up a little bit. So I've got negative, and I've got cos over sine, which is cot, and then another 1 over sine, which is cosec. So negative cosec x cot x. Okay, another one that you should try and memorise. Okay, and of course you need to know the method of doing that. I've left myself space for this one, so I can actually keep that there without erasing it. Like this one, you can do one of two ways. What I'm going to do is, just to be consistent with my work on the board here, I'm going to write it as tan x to the power of -1. I'll explain the other way once I've done this. Okay, so tan x to the power of -1. Then we have dy dx is equal to, and that will be negative tan x to the power of -2. And then we differentiate tan x. Remember what that one is? Sec squared x. There we go, sec squared x. And then we'll just tighten it up a little bit. So we've got, now it's going to be negative sec squared x over tan squared x, which is not really how you want to write the answer, is it, okay? Particularly since sec squared x is 1 over cos squared x. So what I'm going to do is, while you're thinking about that, and I'm making up an excuse for this little bit of time that I'm wasting by just writing this out again. What did I say that was again? Negative cosec x cotx. I did say it's useful to be able to memorise these, didn't I? Yeah. And then this one, so negative sec squared x. That's the same as negative 1 over cos squared x. And then 1 over tan squared x, that's the same as cot squared x, which is cos squared x over sine squared x. So that's this written in terms of sine and cosine. And then these two will cancel. You're left with negative 1 over sine squared x. So that's negative cosec squared x. Okay? And then those are the results. All right, just remove that. Okay? So I'm hoping that you followed that nicely. Okay? In summary, let me just show you here what the results are. Here, of course, with these which I've used already, okay, but you need to know these 6 trigonometric results. So there you go, secx becomes secx tan x, differentiate cosec x, negative cosec x cotx, differentiate cotx, negative cosec squared x. Okay. I did say as an alternative to differentiating cotx, what you do is you can write it as cosine x over sine x, because that is what cotx is, and then you can use the product rule, quotient rule. Sorry, use the quotient rule to do this, because obviously it's this divided by this, but you can use the product rule, I suppose, have cos x and sine x by -1, but quotient rule is best. Okay. If you want to do that, you can do that, and then you should end up with that as your general answer. Okay. I'm hoping you're happy with that. Okay, just here we are, these results, and you can need them for the questions that are coming up next. Right? So these ones involving the derivative of secx. Okay. As a reminder, that's the derivative of secx, it's secx tan x. Maybe pause the video, have a go at these 3 questions. Unpause when you're ready. I'm going to go through them now. So they're all using the chain rule, these questions. Okay, I'm not putting any product rule or quotient rule questions up for this, but you should really practice those in your own time, because these sorts of things can also come up with the product rule and chain rule too. So here what we're going to do, well, when we differentiate sec, we get sec tan, and the angle stays the same. Remember, I've talked about that in my previous videos. So because the angle is half x, then the angle when we derive it, differentiate it, is going to be half x as well. So it's going to be something involving sec half x tan half x. Okay? And then what we do is we differentiate the half x to get half multiplied by 5. So it'll just be 5 over 2 sec half x tan half x. Okay, hoping that was okay for you. If not, you can just re-watch the video if you want. I'm going to shift this one along a little bit, because I've encroached a bit on the working space there. Right, this next one, so y equals, by the way, I'm always in the habit of writing y equals dy dx equals. I hope you are as well. I really do dislike it, even hate it, when students just kind of write that, or even worse, when they just write that equals that, which equals that, because that's just wrong. Okay, it's useful to know what the derivative is and what the actual function is. Okay, remember, you'll be differentiating and integrating by the time you've completed the syllabus, and you need to know what is what. It doesn't cost you anything to write dy dx, so just do it, and it helps the examiner know what your differentiated answer is. Anyway, let's look at this. So sec of that, so that's the angle in brackets. So our answer's got to be something to do with sec 2x squared minus 3x tan 2x squared minus 3x. Okay, I'm just going to put this other question to the side there. Okay, so notice how that works. When you're differentiating sec, you always got sec the angle, tan the angle. The angle never changes. Okay, so this is the angle, so just put it in there. Then we differentiate what's in the brackets, and that becomes our coefficient. Okay? So differentiate that, we're going to get 4x minus 3. Just squeeze it on there. But the bracket is a bit large, isn't it? There we go. That's it. Really is as simple as that. Okay. Right, next one. I'm just going to clear the screen if you don't mind to do the third one I put up there. So here we go. And let's look at sec squared x, shall we? So here we go. If you see my previous video on differentiating sine squared x, cos squared x, tan squared x, you notice what I suggested was that you can write it like this: sec x to the power of 2, because that means the same thing. Just that our convention of writing this is we put the squared there. isn't it? Sec squared x. Okay? But that's what it means. It might just help you in terms of knowing how to differentiate it. I'll just put my working down here now actually. So when we differentiate it, bring the power down to sec x to the power of 1, decrease the power of 1, which is just sec x. Then differentiate what's in the brackets. Differentiate sec x, get sec x tan x. Okay, I'm just writing like this for the moment. So here we go. You can see my working, how we've actually got that. Then our final answer is going to be 2 sec squared x tan x. Okay, I hope that was good for you. Next, I'm going to do another one. Okay, this time I'm going to say, let's look at what happens when we try to differentiate y equals, let's be bold, shall we? Let's just go straight into sec to the power of nx. And then you can write this down as a general result. Okay, we're using the same principle. You can write that as sec x to the power of n, then put the power in front, so it becomes n sec to the power of n minus 1 x. I'll just shift this along a little bit. Yeah, these whiteboards really are good, aren't they? I mean, I remember doing this when we just had, whiteboards, and blackboards even. Okay, that's the thing. Blackboards are chalk. You couldn't just grab a whole section of text and push it over. No. But in those days, I did actually have larger boards as well. Okay. Given a choice, what I prefer. I like having large boards in my classroom. I like having loads of board space in my classroom. I've not finished this as well. So n sec to the power of n minus 1x, then differentiate the sec x to get sec x tan x. So you can see the similarity between this here and this here, I'm hoping. And then that will simplify to n sec to the power of n x tan x. So notice that because the derivative of sec x is sec x tan x, the derivative of sec to the power of nx actually ends up being something involving sec to the power of nx because of this here when you multiply these two together. Okay. Just a reminder, when it comes to integration, you have to know this in reverse. Okay, and that's an inspection question. Okay, no working needed. It's what's called the reverse chain rule. Right, let's move on. Now let's have a go at these questions. Pause video, have a go. I'm going to do them now, assuming that you might have done the pausing bit already. So this one here, so dy dx is going to be equal to, now differentiating cosec, we get negative cosec cot. Okay. Now I'm hoping that you're reasonably with it and you know that at some point we have to differentiate the 5x. We'll do that now, shall we? Differentiate 5x, you get 5, times it by 7, you get 35. So it's going to be negative 35. And then we have cosec cot. So cosec, the angle is 5x. And then cot, the same angle, 5x. Okay. That was relatively harmless, wasn't it? Did it all in one go. Next, let's do this one. I'll tell you what I'm going to do. I'm going to put this one down by here. Let's see if I can get away with that. And I'm going to try and do this one in one line as well. Okay. Or rather, I'm going to do it in one line, and I'm going to hope that you understand it too. Okay. So, at some point, of course, we'll have to differentiate x over 3. That's 1/3 x, so you get a third. And then times it by 3, we get 1. It's quite nice. Okay, the coefficient is just 1. And you've got negative cosec, differentiate that, you get negative cosec cot, so the negatives will cancel out. So it's just going to be cosec, the angle, x over 3, cot, the angle, x over 3. Okay. Happy with that? Just a reminder how those coefficients cancel each other out, so the 3 multiplied by a third, and then negative multiplied by the negative, so just cosec x over 3, cot x over 3. Okay. That was quite a nice question. This one here, so y equals cosec squared x. Similar thing again, I suppose. You could write it as cosec x to the power of 2. Bring the power down, so you get 2 cosec x, and then differentiate the cosec x. You'll get negative cosec x cot x. Let's write it like this, shall we? So it becomes obvious what we're doing in terms of the working. Negative cosec x cot x. and then we just write it in a nicer form, okay? So it's going to be negative 2 cosec times cosec is cosec squared x and then cotx. Okay. Right, what we're doing next is we're going to just have a look at the general result of when you differentiate. I think see what's coming up. Cosec to the power of nx. So y equals cosec to the power of nx, and we'll see what we get. So similarly, you can write it as cosec x to the power of n. I'm just going to go straight to the dy dx part. So bring the power down. N cosec to the power of n minus 1 x. Then differentiate the cosec x. You get this. So that's going to be negative cosec x cotx. And just about squeeze that one in, and then I can just simplify the answer. So negative n cosec to the power of n minus 1 plus 1, so that's going to be the power of n, x cotx. Okay, again notice how when you differentiate the cosec to the nx, the power there doesn't change, because while you decrease the power by 1 there, you need to multiply it by cosec again, so still power of n. Right. Finally, let's have a look at these ones in terms of cot. So the first one, I'm just going to write down the answer. Tell you what, I'm going to stick with the black pen for the moment. So here, differentiate 2x, you get 2 times by 3, so you get 6 as the coefficient. Differentiate cot, you get negative, so put negative there, and it's going to be negative cosec squared, whatever the angle is, okay? So notice how, because we differentiate cot, you get cosec squared, negative cosec squared, it's going to be cosec squared of the same angle. I hope you found that one easy. Right, next one, so dy dx is equal to differentiate 3x, you get 3, times by a half, you get 3 over 2. Right, and then differentiate cot, you get negative something, so the negatives will cancel each other out, and that's going to be 3 over 2 cosec squared 3x. Okay, that's that one. And then finally, cot squared x. Let's just move this up along a little bit, shall we? Right, so I suppose being same way I did before, I'm just going to write it as cotx to the power of 2. So when we differentiate that, we're going to get, bring the power down, 2 cot x to the power of 1, then differentiate cot x, we get negative cosec squared x. Let's just write that in here, negative cosec squared x, and then just write it in a slightly better way. So negative 2 cosec squared x cot x, or 2 negative 2 cot x cosec squared x. Okay. Next, let's just finally have a look at, do you predict what I'm going to do next? Just change the colour. Yeah, we'll look at y equals cot to the power of n x, and we'll differentiate that. Okay. So dy dx is equal to, I'll bring the power down, so it'll be n cot to the power of n minus 1 x. Derivative of cot x is negative cosec squared x, and then just write it in a better way. So it's going to be negative n, how do I write this? Cosec squared x cot to the power of n minus 1x. I've just done it like that because of alphabetical order, really. No other reason. You know, cosec comes before cot in the alphabet. Okay, so that's the only reason why, in case you're wondering, I wrote the cosec before the cot term. Okay, just check that. Yeah, that's it. Yeah, that's it. That's all done. But as I said previously, make sure you memorise these results. Okay, because when you're doing questions like I just worked through, it's a big time saver, a massive time saver, just to have in your head what the derivative of secx, cosecx, cotx is as well. I'm hoping by now, by the time you've got to this video, that you've memorised these three already. Okay, right, that's it. Okay, hope you got something out of that. I'll see you again soon.